Okay, so this is a really short segment on ions of the periodic table, but it's kind of a really important idea, so I just wanted to have it so you could review it like in a short video. Okay, so we'll try to keep this under like 5 minutes. So in terms of the periodic table, we knew metals lose ions, right? And electrons, and nonmetals gain electrons. But here's the thing: when ions are formed, they try to match electrons with the closest noble gas. So let's look at magnesium, right? Magnesium. And I have magnesium right here. Now, what's the closest noble gas to magnesium? This is a mistake students make a lot. They look at argon, but the closest one's actually neon, like this. So what it means is argon is going to lose 2 electrons, because it's got 12 right now. It'll lose 2 to become like neon, right? So when we look at magnesium, the most likely ion that magnesium makes, based on its position in the periodic table, is a +2 ion, because it's close to neon in the periodic table. Now let's look at the same thing for iodine, right? And we would just, actually the name of this is just magnesium ion. Now if we want to look at something like iodine, that's a nonmetal. Nonmetals gain electrons. So we're going to go back to our periodic table, right? And we're going to look at it and say, well, where is iodine in the periodic table, right? And you'll find it down here. Now the closest noble gas, right, is xenon. I went over the X. It's a xenon. So that has 54 electrons, right? So that means iodine, in order to form an ion, right, has to pick up 1 electron, because it'll go from 53 to 54. So as a result, right, when iodine forms an ion, it forms an I- ion, the anion, right, picks up 1 electron, is what we would say, to form iodide ion. So iodine, right, we name it as IO, and then we get rid of the INE and put I died. Iodide. Okay, that's what it gets replaced with. So for the anions, for the cations, we just say cation, but for the anions, we add the IDE suffix, and actually that's kind of important because it helps us to designate whether it's a cation or anion, and when we do naming, it helps us to designate where the end of the name is, right? So we'll do some practice, right? You're going to look up sodium and oxygen, and then you'll figure out what their ions are, and then I'm going to pause it. I'll write the answer, and then we'll look at the periodic table and get back. Okay, so those are the ions. By the way, the noise in the back is my 2 kittens fighting with each other. They're playing chase. I don't know if you hear it. It's actually pretty loud. We'll go back to our periodic table, and we're going to look up sodium and oxygen. So here's sodium, right? Sodium is closest to neon, right? Just like magnesium was closest to neon. So in order for sodium to make an ion, it has to lose 1 electron. So when we go back to here, right, sodium loses 1 electron, which means it has a positive charge, because I have 1 more proton than electron. Now when oxygen does this, right, oxygen, let's look and see where it's at on the periodic table, right? It's here. And oxygen also is closest to neon. So these noble gases turn out to be really important, right? We use them for the reference point for a lot of things. But it has 8. It needs to pick up 2 to be like neon. So its charge will be -2. Now, just in general, okay, and I do this, it's kind of a little ahead of time, but I like doing this because I think you'll understand it. We can use the periodic table to find an element, right, whose common ion, that's what we refer to these ions as, have the following charges. It'll be either -3 or +3, okay? So what we'll do is we'll think about what that means. All of the elements that are -3 need to pick up 3 electrons. So we're going to look for the group, right, that has these. So if we go like this onto the periodic table, elements that would pick up 3 electrons are in this group. All of these guys, nitrogen and phosphorus, pick up 3 electrons. It turns out arsenic will as well, like a nonmetal. even though it's a semi-metal, because nitrogen will pick up 3 and become like neon. Phosphorus picks up 3 and becomes argon, and arsenic picks up 3 and becomes like krypton. Now, for an element to make a +2 ion or a +3 ion, right? Let's go back to the question. Oh, shoots. Didn't mean to do that. To make a +3 ion, it has to be able to lose 3 electrons, right? So which elements can lose 3? And this is where it gets a little bit weird, and I just want to show you this. Okay, I did it again. This is where I really want to go. Wait, no, that is not where I wanted to go. I wanted to go here. To become +3, right? One element that does that is actually aluminum, because it's going to lose 3 and it's going to go from 13 to 10. Okay, it's just that it's separated by this transition metal. Another one is this one. So even though they're not in the same group, right, they have the same ability to form a +3 ion, because if you count to the left, right, you get to, for scandium, you get to argon, and for aluminum, you get to neon, right? Well, there's some other weird things. Gallium often makes a +3 ion, and indium makes a +3 ion. And why that happens is going to be hard to understand until we cover more like atomic theory. Yttrium, though, also makes a +3. That makes sense because it becomes like krypton. So it turns out group 3A and group, that's this one here, right? And group 3B, which is actually this one, that group number helps us figure out what the charge is. In general, because of this property, right, group 1 tends to make a +1 ion. Group 2 tends to make a +2 ion. Group 3 tends to make a +3 ion. Now, groups 1 and 2 turn out that's the only ions that they make. And then if you're looking at negative ions, fluorine, chlorine, bromine almost always make -1. Oxygen, sulfur, selenium, tellurium all make -2, right? Nitrogen, phosphorus, arsenic, I don't really know about antimony, but those will generally make -3. And carbon and silicon, but not often, but carbon can also make a -4 ion. Okay, so that's the idea. Position on the periodic table, which is the important point of this segment, can help you predict what the charge of ions will be.